Hello students, welcome to Inside Physics. In this session, I will explain an alternating current given to an resistive circuit. What is the observations? We all know alternating current. The direction and the magnitude of the current is alternating. So here the direction of the current will be alternating and it changes along the positive side and the negative side, and it varies sinusoidally like a sine curve. That is what alternating current is all about. The direct current will not have any changes in the direction, and it is produced by the direct current is produced by the batteries and the storage cells. Here the alternating currents are generated from the coils when they actually turned around in between the strong magnetic fields. So there the magnetic flux will be cutting the coil turns, and the changing magnetic flux will produce the EMF inside the coil, and the vice versa. Also the changing rotating magnets, that means the coil will be stable and the magnetic field will be rotating. So either way we can produce the alternating current with changing magnetic flux. Here I will give you a circuit which is a purely resistive circuit where an alternating current is given to the resistor. This is the symbol, this is the sine curve symbol, because the AC current or AC voltage is varying sinusoidally like a sine curve. The source of AC current is given like this, and here the potential difference across its terminals is varying sinusoidally. This is the resistor. So here the potential difference can be given by V is equal to Vm sine omega t. Omega is the angular frequency of the oscillating current, and you know the oscillating current means the voltage and currents will be like this. Okay, if this is the current showing and the changing in direction means in the positive side it has minimum and maximum value, again it has come to the minimum, and in the negative side also there is a maximum value, and here this is Im maximum. So here also there is a value on the other side in the opposite direction, this is called minus Im. So this is how the current will vary because of the change in its direction. We can show like a sine curve. In the same way, if you take the voltage potential difference, actually the source will first give the alternating voltage. The voltage potential difference will produce the current in the circuit. So if you take this as a voltage curve, this is also having some maximum. This is the amplitude of the voltage on both sides, and this is minus Vm. We can show the curve like this, like a sine curve, and the oscillation of this voltage and thereby current in the circuit will vary like a sine curve, producing same values on both sides. Here it is the Vm is the maximum amplitude of the oscillating voltage, omega is the angular frequency of the oscillation at a particular time of instant. So here this is a simple resistive circuit. By applying Kirchhoff's second law, what is the second law? All the EMF in a closed circuit, the algebraic sum of all the potential differences in a closed circuit, that means epsilon I is equal to 1 to n is equal to 0. If there are n EMFs. That means there, if in some circuits there will be more number of arrangements like capacitors, inductors and resistors. In that case also, Kirchhoff's second law says sum of all the potential. It is also called loop rule. So according to this, we can write this. See, V M sin omega t. This, see, when the this is the current is passing in this like this, and we can write this as IR is equal to 0. So by this we can write IR is equal to Vm sin omega t. Okay, so here I is equal to Vm by R sin omega t. Remember, I have written this equation according to the Kirchhoff's second rule, that is voltage rule or loop rule. So by this, I is equal to Im sin omega t. Here this one Vm by R can be written as Im sin omega t. So this implies, see, from these two equations we can write Im is equal to Vm by R. So here this looks like Ohm's law. Ohm's law is applicable to both AC and DC voltages, and here the resistance is constant. This maximum current is like this. So from this we can imply that Vm is equal to IMR, which is like Ohm's law, and this one is having the relation in alternating currents also. So here, see, the direction change, the instantaneous current across the sum of instantaneous currents at a particular time will be 0, because if you plot a graph between the current and the voltage, see, this is the phase difference between this. If you take this curve as current and this is the voltage, so the minimum is at 0, pi and 2 pi, and here the maximum values are also reaching at the same time. See, here the maximum has reached at the same time for both current and voltage, and here also the minimum has reached at the same time. So maximum and minimum values are reached at the same time, so these current and voltage are considered to be at the same phase. Okay, the phase difference is 0. That means there is no current lagging behind the voltage or current is going forward the voltage. The current and voltage are at the same phase, and the phase angle between them is also 0. So here, if you take the average current, why we need to take the concept of an average in this alternating currents means, if the current is keep on changing like this, that means actually in this pictorial graph the current is shown like a sine curve, but actually the direction of the current will be this back and forth, forward and backward. So that is shown in the graph like this. We all know when a coil is rotating between a magnetic field and the magnetic flux is cut by the coil, there is an induced EMF in the coil. That EMF actually is the potential difference that produces the current. in that coil. So here the sum of instantaneous currents across this current and voltage will be 0. That means the average current or average voltage is 0. That means sum of instantaneous currents means if you take the current here and the corresponding value is here, and if you take the current here and the corresponding value positive and negative, the sum will be 0. The average value of the current is 0 because they are having same values on either side, positive side and negative side. Here the power, it doesn't mean that voltage and current or the average current average voltage is 0 means doesn't mean that there is no power consumption in the circuit. There is a power consumption, and how we know that there is a power consumption? There is a consumption of power, there will be a wastage of power also. We know in the electrical wires across potential difference, the current is flowing across the electrical wires, we can see in our homes and in our offices. The current flowing is obviously power is consumed by the electrical gadgets, and there will be some wastage of power also, dissipation, power dissipation, and the electrical energy, some of the electrical energy is lost during transmission or usage by the electrical gadgets. So this power dissipation is actually indicated by the Joule's heating effect. Whenever there is a heat produced by passing some electrical energy, the power dissipated, power wasted is actually indicated by I square R, current flowing and the resistance in the circuit. So here if you put I value, what we got here, I m sine square omega t r. Okay, so this is the power dissipated, and all in all if you calculate the average power, so for average power we use the symbol Im and R are constants here, and we need to take the average for this value sine square, average symbol, this is the symbol we give for the average value, this is the symbol. There will be some variables here, and for that variable like sine square omega t we take the average value. So how to take this average value means we know that sine square omega t is equal to 1 by 2 into 1 minus cos 2 omega t. This we know by the trigonometric functions. So here cos 2 omega t is the variable, we need to get the average for this value here. Okay, so here we take the average of a function cos 2 omega t. How to get the average of any function? That means if f of t is a function over a time period, if f of t is a function working between the time period 0 to t, then the average of this function in this time limit can be taken as integration of the limits f of t dt. In the same way, if you take this function and get the average, that means here 1 by t 0 to t, what is the function? Cos 2 omega t dt. So this will be written as, the integration is done and we know that here sine omega t. If you substitute the upper limit, this will be 2 omega t. Okay, sine 2 omega t integrating, and this will be the formula for integration of cos 2 omega t is sine 2 omega t. After substituting the upper limit, this, see, this value is 0. We know that sine 2 omega t, this value will be 0 and this term will be coming to be 0. So this cos 2 omega t is 0 because this term is always 0 and this entire term will become 0. So here what is the value? Sin square omega t will become 1 by 2. Okay. So here what is the power? We have average power, we have written P square is equal to I m r into average of sin square omega t. So in place of this one, if you put 1 by 2, average power is equal to 1 by 2 I m r. Here see, half I m square, here the square we need to put a square here because the power we have written in the beginning is I r, and in the place of r here also there will be a square. Actually we have taken I m sin omega t whole square into r. That is why we need to take square also here, half I m square r. Okay. This is the average power, right? So average power has some positive value. So that is why we need to understand that even though the average current and voltage are 0, there is an power consumption is there and also dissipation is there. So the power will not be 0. Here, because of this alternating nature of this current, we introduce a concept of RMS value, because the RMS root mean square value will be, it is customary to measure in all electronic circuits and electronic equipment. The RMS value we will take is actually gives the current, voltage and current passing through the circuit. So for example, this value is given by IRMS is equal to IM by root 2. Okay. So this will be around 0.707 IM. This will be around 0.707 IM. So in the same way, voltage or root mean square voltage is also Vm by root 2. In the same way we can take. So here how to get this IRMS? It is also represented by I. I is equal to root of I square. That means here root of I, this Im square by 2. Root mean square. Okay. So this will be coming to as Im by root 2. What is the purpose of RMS voltage or RMS current? So in generally for our household purpose, we get the alternating current from the mains supply. that is actually produced by the producers. Alternating current will be transmitted to our homes and it will be uplifted by the transformers in which the voltage is lost. So the mains power supply in our homes will be actually giving the alternating current. So what is the voltage that will come into our homes? That is the RMS voltage only. The voltage we use in our homes is 220 volts, which is RMS value. Okay. So what is the actual value? If it is the root mean square value, we know that Vrms is equal to Vm by root 2, and Vm maximum voltage coming means this is equal to Vrms into root 2, that is 220 into 1.414. This will be coming around 311 volts. Okay, this 311 volts is the actual alternating current potential difference voltage that is coming through our actual mains supply. So this RMS value is the actual value potential difference we are actually having in our homes. So this is the concept of RMS current and RMS voltage. So if you take a graph for the voltage and current, I already shown that both the current and voltage will be having its minima, maxima and the highest peak values at the same time. Okay, so this is the pure resistive circuit, and when an alternating current is given to an inductor or capacitor, how to get the value of the current and how we will calculate the RMS value or average current or average power. We all know the details in the next video. Here we also can write this same thing like this, root 2 by R. Okay, this will be like, so V RMS is equal to, this is the RMS value into resistance, which is coming like a Ohm's law relation, right? So even it is an RMS current or average current or it is a DC current, so the Ohm's law will be valid for all the purposes in every circuit. So this is all about the alternating current given to a simple resistive circuit. Thank you.